Hello everyone, myself Sanjay Vikasini. I am currently pursuing data science and business analytics internship with Sparks Foundation. And my second task is regarding unsupervised machine learning where the input data set is not labeled. And the task is to predict the optimum number of clusters from the given iris dataset and represent it visually. So this task involves clustering, that is grouping of similar objects into a single category. So the first step is to import the necessary libraries, which in this case includes NumPy, Pandas, Matplotlib, and Seaborn. And the second step is to import the dataset. The dataset is provided by Sparks Foundation. So the comma separated values is converted into data frames by Pandas library. df.head displays the first 5 rows in iris dataset. So iris dataset has 5 important attributes: sepal length, sepal width, petal width, and species. Based on these 4 attributes, iris flowers are categorized into 3 important categories: iris setosa, iris versicolor, and iris virginica. And these values are present in centimeters. df.tail displays the last 5 rows in iris dataset. Since the ID column is not necessary, it is dropped. df.info displays information about each column. So each column has 150 values. df.describe displays a statistical analysis of each attribute. This particular piece of code displays the summation of null values in each column, which is 0 in this case. .unique displays the different species present in the dataset, that is iris setosa, iris versicolor, and iris virginica. .value counts displays the number of flowers categorized into each category of iris species. So in this case, each category of iris species has 50 values assigned to it. So there are 50 flowers for each category. And the third step is to perform exploratory data analysis. So the first visualization technique used is histogram, where the values are plotted in the x-axis and the density or count is plotted in the y-axis. So the first attribute chosen for plotting the histogram is sepal length. So x-axis consists of the sepal length values in centimeters and y-axis consists of the density or count for each of these values. And this is the histogram plot for sepal width. This is the plot for petal length, and this is the plot for petal width. So the second visualization technique is correlation matrix, which displays the interrelationship between two features using heat map. So df.core displays correlation matrix, where each of these attributes are assigned values by comparing with other attributes. So the value 1 shows that both the columns are the same. So this is the heat map for iris dataset. So the diagonal white boxes shows that these values are the same. And this black boxes shows that these attributes are distantly related, like petal width and sepal width. Petal length and sepal width are distantly related attributes. The fourth step is label encoder. That is, in order to find the optimum number of clusters for iris dataset, the string values present in species column should be converted into numerical values. So in order to perform this task, label encoder package is imported from the scikit-learn library. So this transforms all the string values present in the species column into numerical values. So 0 value is assigned for iris setosa, 1 is assigned for iris versicolor, and 2 is assigned for iris virginica. And the most important step is to find the optimum number of clusters. So the variable k is used to denote the optimum number of clusters. So the very important step in finding the optimum number of clusters is to plot the WSS plot. WSS plot is within sum of squares plot, where the clusters are plotted in the x-axis and within sum of square values are plotted in the y-axis. So what is sum of squared error? So if you observe this graph, there are two clusters and each cluster has one centroid. So sum of squared error is the distance of each data point in the cluster from the centroid. And if these values are added, this gives the sum of squared error value for this particular cluster. So the sum of squared error values obtained for each of these clusters is added to get the cumulative value. And these values are plotted in the y-axis. And the optimum number of clusters is found using the elbow method, which we'll be seeing now. So the k-means package is imported from the scikit-learn library. And first, the within cluster sum of square values are found. And this is the final WSS plot. As the clusters are plotted in the x-axis, and within cluster sum of squares is plotted in the y-axis. So this shows the structure of a elbow, and the kink of this elbow displays the optimum number of clusters. So the kink is occurring here. So the optimum number of clusters required is 3 in this case. And the next step is to train the model. So the model is trained using the k-means package, where the number of clusters is 3, and the maximum number of iterations is 300, and the number of iterations of the k-means algorithm for different centroid values is 10. So 10 different centroid values is used for this plotting this algorithm. And these are the predictions values. And 0 indicates iris setosa, 1 indicates iris versicolor, and 2 indicates iris virginica. And the last step is to visualize the clusters. So the clusters are visualized using the scatter plot. So this is a scatter plot for sepal length and sepal width. And this is for petal length and petal width. And this is for sepal length and petal length. And this is plotted for sepal length and sepal width. Thank you.